Hello students. Next let us look into another very important theorem that is used in network theory, and that is the superposition theorem. The superposition theorem, as you can imagine, has something to do with superpositioning. Superpositioning means if you are having two quantities, then you add them up. You add the two quantities. That is superposition. If you have two waveforms, you take one waveform and on top of that you put another waveform, adding it. So something similar is there in the superposition theorem. What it basically means, first I will understand, I'll just tell you what it means. What it means can be understood by looking at this particular circuit. In this circuit, there will be a current that will flow in R3, and that will be because of this source as well as this source. What superposition basically says is that if you want to find out what is the current here, the current will be composed of two parts. The first part will be the current due to this voltage source, and the second current that will be here will be because of this current. The current will be because of this voltage source, this current source. Let me draw that again. The second current will be because of this current source I1. So the total current that is flowing in R3 will be due to a current because of V1 and a current because of I1. And that is what is our superposition theorem saying. That if you want to find out the total current, consider that there is only one source at a time, and consider that there is no source. The other sources are all made zero. All the other sources. Here I have only shown two sources. If you are having three sources, then when you consider one source, then you consider all the other sources to be zero. Okay? And find out that current, first current. Then you consider the second source while considering the first source and the other sources all zero. When you consider that source while you consider the other sources as zero, because of that you will get another current here. The addition of both those current, one because of the voltage V1 and another because of the second source, which in here our case is I1, that is going to be the total current. So we have superpositioned the effect of V1 with the effect of I1. Just like that, if there are multiple sources, if there are three sources, then find what is the effect of one source, second source, third source, add all of them up, and you will get what is the combined effect of all the sources put together. That is what is superposition theorem. Let us look at the statement. You can pause the video here and write this statement because sometimes it comes in the examination as such. In a linear network, what is the meaning of a linear network? Linear network means a network which contains only resistance, then inductance, capacitance. They are a linear source. Okay. In a linear source or in a linear network containing more than one independent and dependent source. Okay. The case of dependent source I will talk little bit later. So if any linear network has more than one independent and dependent source, the resultant current in any element is the algebraic sum, that is addition, of currents that would be produced by each independent source acting alone. That is the important statement. Each independent source acting alone. So you have to consider each independent source when the other sources are all made 0. What is the statement? All other independent sources being represented meanwhile by their respective internal resistance. That means you make the other independent sources 0. See, if you are having a voltage source is always represented by an internal resistance of 0. So it is basically a short circuit. Whereas if you are having a current source, the current source is always represented by an open circuit because its internal resistance is infinity. Okay, so when we say all other independent sources being represented meanwhile by their respective internal resistance, when they mean what they mean by internal resistance is that for a voltage source the internal resistance is 0, that means short circuit, and for a current source the internal resistance is infinity, so it's an open circuit. Okay, so that is a simple statement. Now what are the steps to be done? So the step is find the current through the resistance only when one independent source is acting, replacing all other. Now what all can be there? There can be an independent voltage source, we replace it by a short circuit. There can be an independent current source, we replace it by an open circuit. And this is very important, that's why I wrote it in a different color. Do not, and I repeat, do not replace the dependent source. You should never replace the dependent source. Okay, be careful about this. People make a mistake because they go behind changing the dependent source, and that's where you will lose mark drastically. Once you have done that blunder, the people who are there to correct, they will simply think that okay, you have not understood superposition at all. So don't make that blunder. Always take care that you do not replace the dependent source by anything. You leave the dependent source as such. We will see problems pertaining to that. We will see numericals wherein we have dependent sources later. Okay, now so this first step that we do for one source, we do it for all the sources one by one, and that is the second step, which is repeat the above step for each independent source. And then the last step is now find the total current in the element by superpositioning, that is adding all the current due to each independent source. That's all. So let us look at a simple example. Okay, here I have not put any values. The green represents the resistance through which we want to find out what is the current. Okay, now what superposition says is that this current is composed of two currents. One is the current because of the source V1 acting alone, and the second current is due to the second source, which in our case it is the current source I1, which is acting alone. So when I say acting alone, it means the other is made 0. When we make the other 0, the voltage source becomes short circuit, and if the other source is a current source and you make the current source 0, it is as good as drawing it as an open circuit. So here the current that I will find out, that will be the current only because of V1. And how do we find out? We know that we can use the mesh. Okay, we can use mesh. Let's say this is IA and this is IB. Then if I use the mesh analysis, this is basically our IB. Correct? Similarly, so here what I have done, here I have basically replaced the I1 by its internal resistance, which is basically infinite resistance, which can be represented by a open circuit. So the open circuit, if you keep this one as open circuit, then it's as well as not there. Okay. Now in the second case where I have to make the voltage source 0, I have put the internal resistance as 0 ohms, because of which what we are having is a short circuit, and there is a current source, and because of which there will be a current. Now very importantly, you have to remember this very clearly. I will draw for both the cases the current in the same direction. Okay, why? Because I have drawn the same direction current that I have drawn here. Generally, if you are going to get a question, you might be getting it in either of the two ways. They will draw the direction and give you, or they will not draw the direction. If they have drawn the direction, take only that as the direction, and that same direction should be taken in each and every case. So this one will be I, the current I, because of source I1. Okay, and if I am going to use mesh analysis, or even I can use nodal analysis, let me use mesh analysis because that is the preferred choice by most of the people. So here also some IB current and some IC current. So this is going to be equal to this IB. Okay, now don't consider that this and this IB are going to be same. No, I have just did it as an example. So both the cases it came out to be IB, otherwise you have to find out. Okay, now when we do this, you have to be very careful. If the answer is coming out to be negative or positive, this one suppose it comes out to be positive, you add both of them up. When we add, we have to take care of the sign convention. So if this comes out to be, suppose 5 amperes, and this comes out to be minus 3 amperes, then the addition of both of them will be 5 minus 3. Why? Because it's a minus sign, isn't it? So 5 minus 3 will give me 2 amperes. So generally, if I have to draw, I will say that, if I have drawn a resistance like this, I will say that I have got a current 5 amperes flowing through the resistance, and this minus I can actually represent it by opposite direction. So I will say that I have got a current going in the opposite direction, which value is 3. So this is basically minus 3, and this is 5, positive 5. Okay, and when you add both of them up, since they are both in opposite directions, the value, you should not write it as 8. Don't write it as 8. That is where most of the people make another mistake in superposition. Always take care of the sign in case of superposition, because the sign basically tells you what is the direction in which the current is flowing. So if I have got the first current as 5 plus 5 and the second current as minus 3, it means that those currents are opposite. Now, when I said the second case, that means if I am not having the current flowing in this direction, okay, if suppose I am not having the current flowing in this direction, okay, I am having the current flow in the other direction, the opposite direction. For example, let's take that the current is flowing in this direction. Then for this case also I have to consider this. In that case, this current will be minus IB. Why? Because the direction of IB is like this, and this is in the opposite direction. So I will consider this as minus IB. So actually it will come, if it was previously it was 5, it will come as minus 5. And here again I will have to consider in this direction. In this direction it will be again minus IB. So previously if it was minus 3, then it will become plus 3. And then if I add minus 5 with plus 3a, I will get minus 2. It means that my net current is flowing in which direction? My net current is flowing in the opposite direction that I have drawn. I have drawn this direction, but because my answer is minus 2, so it will flow in the opposite direction. So you have to take care that in the question, have they drawn the direction of current? If they have not drawn, you assume and then you do as such. If they have drawn, then based on that you should get the answers. Okay, so now let us do a problem based on superposition theorem. Thank you.